Very pleasant good morning. In this video session, I am going to talk about data mining techniques. First of all, we should know what is data mining. Data mining is a extraction of knowledge from the large data set. So here we are going to apply one of the important techniques, classification and prediction. So before that, we should know what is classification and prediction. Classifications and predictions are the two forms of data analysis that are used to extract the models. Using those models, we are able to predict the class label or to predict the feature trends of our data. So, alternative name for the classification is also called the supervised learning. Here we considered two different kinds of data set. One is called training data set, another one is called as a test data. So training data, it is a form of or subset of original data set that is used to learn a classifier. So training data are labeled or consist of labeled data. So new data that is called unlabeled data that is considered as a test data. So here it is example for the training data. So the age and income. According to the age and income of the customers, we can predict the class label whether he is a budget spender or big spender. So using those trained data, we are able to create or build model. So using those model, we can classify the tuples whether he is a budget spender or big spender. What's the principles behind the construction of the model? So to construct the model, we need to use mathematical functions to train based on some training examples. Here, describe and distinguish the class or concept for feature prediction and prediction some known class labels. In order to predict some known class labels. So here we know the difference between the classification and prediction. So classification means to predict the categorical class label, that is discrete or nominal. Prediction means, so this model consists of continuous valued function, that is it is used to predict unknown or missing value. But classification to predict the class label, that is that is one of the characters data to predict the class label alone. Example, the customer profile should be given as a classifier model, which is predict whether he will buy a computer or he will not buy a computer. That is the outcome of the classifier. So for the examples of prediction, we use that numerical values. The customer profile should be given. So the numerical prediction predictor to predict whether he is, that is the outcome of this representing numerical values. So model or classifier is constructed to predict the categorical labels such as safe or risk for a loan application data. So here the prediction, we are applying regression analysis that is used for prediction. Predictions is a short name for numerical prediction. So these are all the examples. So what way to construct the model? There are two main steps for the classification. First step to construct the model. So first the learning, it involves two steps. One is called as the learning step, another one is or training step. And next step we are going to involve how to determine the accuracy of the model. So when you are going to construct the classification model based on the training data, so the content of the training data should be contain set of tuples. Each tuple is assumed to be belong to a predefined class. The label data should be true, and it contain label data. So how a classification model look like depends upon that what kind of classification algorithm we are used. Accordingly, we can define the classification model. So here the classification model can be represented as one of the following form, that is classification rule, if then rules algorithm or decision tree. So we are using decision tree algorithm or some mathematical formula, that means decision classification or maybe a neural network back propagation algorithm, that are all comes under some mathematical formula. And next we can how to, after defining that classifier model, we can determine the usage of that model. So before using this model, we first need to test its accuracy. So measuring the model accuracy, to measure the accuracy of the model, we need a test data. The test data is similar to the structure of the training data, but it is unlabeled. The test, that is, how to test it. So the known label of a test sample is compared with the classified results from that model. For example, test data, we already know that age equal to 25 and income equal to 30,000. We can determine the class label is a budget spender. So if I giving that input to the classifier model age and income, then we can predict the result, that budget spender. So we can compare the results of the test data class test data class label and then outcome of the classifier. So the accuracy is the percentage of the test set of samples that are correctly classified by the model. So important test data should be independent of the training set, otherwise that is overfitting will occurs. And using of those models, if the accuracy is acceptable, then use the model to classify the tuples whose class label are not known. So this is the way we are giving the construction of the model. So the classification algorithm, we are going to give all the training data by using any one of the classification algorithm to build the classifier. The outcome of the classifier should be whether he is a budget spender or the fixed spender. Depends upon the tuples value, we can determine the class labels by using the classifier. Next, model usage. Here also we are using that after we build the model, that is, this is an example. We can test the data by using the classifier. We can determine the accuracy. How for all the four tuples are correctly classified, we can determine the accuracy is acceptable. If it is acceptable, then we can use that classifier in a real life application. And then what are the issues of the classifications and predictions? There are two types of issues. One is called as data preparations and another one is called as evaluating the classifications methods. So one is data preparations, in the sense it should be comes under three different categories. One is called as a data cleaning and another one is relevant analysis and data transformation and reduction. So data cleaning, in the sense that we need to perform pre-processing steps to be used to reduce the noisy or how to handle the missing values. So in case of missing values, we need to replace that missing values with most commonly occurring value for that attribute. So this is a way to clean the missing data. And second one, relevant analysis. So we have to use some statistical formula, that is correlation analysis, and attribute subset selection. So two techniques that is used to remove the irrelevant or redundant attributes. And third one, data transformation and reduction. Data transformation and reduction in the sense, so we can convert that is data transformed to a generalized data, that is the higher concept level. So normalization in the sense, normalization in the sense we are going to apply that normalizing involves scaling all value for a given attribute so that it will be fall within the small specified range. So the normalizing attribute value means it should become within the specific range, then only it is easy to convert, that is normalized into generalized data. So reduce the dimensionality of the data. It is also used for data preparations. Next we can go for next issues. Evaluations of classifications method. There are 5 ways to evaluate the classifications method. Depends upon the accuracy, speed, robustness, scalability and interpretability. Based on that, we are going to evaluate that classification models. So first one, accuracy. So accuracy means the ability of the classifier correctly predict the class label. Depends on that, we can determine the accuracy of the classifier. Similarly, predictor accuracy, how close the predicted value from the true one. Based on that, we can determine the accuracy of the predictor. Speed in the sense how much time it has taken to construct the model and time to use the model. Based on that, we can determine the speed of the models, classified and predictors. And then robustness in the sense, even the data classifier is working fine to predict the proper class label. Suppose if the data is noisy or missing value, in that scenario, how the classifier is correctly predict the class label. That is called as the robustness. Scalability in the sense how far the classifier should work with a large amount of large data set, how it is efficiently in the disk residence databases. Interpretability in the sense and the level of understanding and insight provided by the models. So based on these 5 categories, we can determine the determine or evaluate the classifications methods. For this, I conclude that or come to the end of this classifications. So thank you.